Okay, everybody, gather around. Okay, linear approximation, what is it? This is the formula that you're going to need to memorize for linear approximation. But what is linear approximation? First of all, they're going to tell you when to use linear approximation. And it's going to follow the exact same formula and same steps every single time. Let's just look at an example to kind of talk us through it. So they're going to give you something that is really close to something that you would know the answer of. So you would know the answer to 1 cubed, which is super similar to 0.99. Okay. First step. See here how it's f of x equals this bullshit? This f of x, is going to be the function that's around the number that's 0.99 or whatever. So our f of x would be equal to x cubed. Then we're also going to need to know the derivative of that function, which is 3x squared. And then notice we have this a and we have this x. You're going to pick an a. Honestly, a lot of the times they give you the a, but you're going to pick an a to be the number that's super close to whatever number is kind of wacky that they give you. So in this case, our a is going to be equal to 1. And then this x is going to be whatever the wacky number is. So x is equal to 0.99. Now it's literally just plug and chug from here. Yeah! F of a is going to be f of 1, so 1 cubed, plus f prime of a, that's just going to be 3 times 1 squared, and then times x minus a, well, that's just 0.99 minus 1. Okay, simplify this a little bit. All right, this is literally your answer. On tests and quizzes, they're not going to give you a calculator for linear approximation. So this would be your final answer. But if you do have a calculator, it's kind of cool to see what's going on with this. Your answer is going to be 0.97 for linear approximation. This f of x is going to be equal to 0.97, which is an estimate for what this number actually would be. So through this method, we get 0.97 as the approximation of this. If we plug 0.99 cubed into the calculator, we're going to get 0.97029, ... which is pretty damn close, honestly. So, cool. Let's try another example. Okay, they're going to be use linear approximation to approximate the square root of 3.99. All right, our first step is to identify what function we're working with here. And we can tell that we're working with the square root function. Okay, so now that we have the square root function, we also need to know the derivative of whatever function we're working with. It's easier to take the derivative of a square root if you change it to this. Take the derivative, that's going to give you 1/2 x to negative 1/2, which is the same as this here. Okay, now it's time for us to find our a. Remember, our a is going to be whatever number is closest to this wacky number here that we know the answer to. And we do know the answer to the square root of 4, which is super close to this. So our a is going to be 4 and our x is going to be 3.99. So now it's time to plug and chug. Okay, f of a, the square root of our a, which is equal to 4, is going to be root 4. Then plus the derivative function with a plugged in times x minus a.
Oh my gosh, bitch.
Cool.
Move out of the way so we can see the 3.99 minus 4. Come on.
Okay, now that we've simplified again, you can leave your answer like this in almost every case. At least I could. But if we plug this into a calculator, we're going to get 1.9975 as our linear approximation estimate for the square root of 3.99. So if we plug in the square root of 3.99 into the calculator, we're going to get this here, which is such an insanely close approximation to what we estimated here. So cool. Okay, first step, identify the function that we're working with. Well, it's something to the 4th, so it's a safe bet to say that our function is going to be x to the 4th. Now, again, we need to know the derivative of that function, 4x cubed. Okay, now it's time for us to pick our a and our x. Well, our a is going to be something that's similar to the wacky number. So it's pretty obvious that our a is going to be equal to 2. And of course, our x is going to be whatever the wacky number is. Okay, plug and chug.
Yeah!
f of a is going to be 2 to the 4th plus f prime of a, which is 4 times 2 cubed. And then, of course, that's going to be multiplied by x minus a. So if we simplify this a little bit, we're going to get this number. This is going to be fine for you to put as your answer on tests. But if we simplify it a little bit more, we're going to get that our answer is 15.68. But that would be our linear approximation, our estimate for what 1.99 to the 4th is. But if we plug 1.99 to the 4th into a calculator, we're going to get 15.6823, which is pretty damn close. Okay, this one looks a little bit different, kind of. Square root of 80. Let's do the linear approximation of it. Well, we can tell that our f of x is going to be just the square root of x, which is, again, x to the 1/2. So when we take its derivative, it's going to be this. Now, remember, for our a, we have to pick a number really close to the original wacky number that we do know the answer of. So if it's going to be the square root of a whole number, just look to the numbers to the left and the right and of it, and one's probably going to be one that you know. So like root 79, we don't know, but root 81 is equal to 9. So our a is going to be 81, and our x is going to be 80. So, okay, time to plug and chug.
Yeah!
Root 81 is our f of a, plus f prime of a, which is 1 over 2 times root 81, times x minus a. Okay, simplify this a little bit. Okay, cool. So this is an acceptable answer, but if we just check to see how close we are, that's going to equal 8.94, 4 is repeating. This is our linear approximation for the square root of 80. But if we actually plug root 80 into the calculator, we're going to get 8.94427. Again, really cool stuff here. If you want more help with this, I'm always available for tutoring at math-savvy.com. Check out the link in bio. All right.